Hi, this is just a follow-up video to an already answered question. Um, uh, the question was, how do you find the linear correlation coefficient on StatCrunch, or the Pearson R value? And Jessica already said it's found under the stat option, and it should be titled regression. Then you just select simple linear, because that's all we actually end up doing. We talked about if they're nonlinear that you'd have to use something else, but that says there are a lot of options once in the screen, but for chapter 10 homework you only need to select the X and Y column and check the box to plot the data. Hope this helps. Okay, so I'm going to do exactly what she said, and then I may make another comment. I'm going to take an example from the chapter 10 quiz. This is the one most missed, or most missed a part of the question, either way. So this is the chapter 10 review quiz. It was number 3, and it said, use the given data set to complete parts A through C. It has a whole data set there. It has the table of critical values for the correlation coefficient, if you wanted to see those here. So it said, essentially, depending on your sample size of your paired data, remember this is paired data, so for example, my set here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pairs of data, x, y. Then I'd come down here to 11, and the critical value we've got to beat is 0.602 if we were having a 5% level of significance, or for a more strict level of significance, a higher level of confidence, we have to beat 0.735. And in the problem, it doesn't state what your level of confidence is, right? And it doesn't state whether or not they want significance levels to be 5 or 1. It doesn't matter, because you'll see in this question, and this was the most missed one, and I think I can assume why, that we're not going to beat even the lower of the two. Sorry, we will beat them, but it won't matter, and I'll talk to you about that why in a second. Okay, so it says first construct a scatter plot. The thing that's nice about StatCrunch is you open the data in StatCrunch, and you can do this for Excel, and you can do this with some other programs, but we're trying to make StatCrunch really ready to go. We have it available on the side in the quizzes, and you'll also have it available right next to the problem during the final. You can click on stat. She said go down to regression, because that's what we were doing, simple linear regression in chapter 10. We were finding correlation if there was any, and if it was linear we would find the prediction line. So we're going to do simple linear regression. These others are for either multiple linear, or if it's non-linear, if it's polynomial or logistic. So simple linear, that's all we did. There it goes. Okay, and what column do we want for the x variable? Well, we want x. How about the y variable? We want y. And this is just so that it'll match up the multiple choice answers that we have. Remember, when we're doing correlation, we could have turned those things around and still checked the correlation level, right? Where, ignore that. Grouped, you can ignore that. So hypothesis test, you can use this, or confidence intervals, you can use that. I think she said she just hit calculate, and she found her R value right there, Pearson R. Correlation coefficient is 0.816. Okay, now she didn't mention about the graphing part, I guess because it wasn't directly asked, but we could do the graphing. So we go under graphics, go down to scatter plot, and choose that x and y the same way as we set it up for the other. It said, do we want points? Yes. Do we want to connect them? No. The order doesn't matter to us here. The size, the point size, doesn't really matter. We can make them a little bit bigger, I guess. the labels, doesn't really matter. Not right now. Title, obviously. Again, just this is helpful if you're doing several of them from different problems and you're leaving them up. It's good to label them. I'll go ahead and draw the horizontal and vertical grid lines because it does on the multiple choice. And we're not having multiple graphs. So okay, so create the graph. Now, it may not look exactly like the ones that are shown in the problem, and here is why, because these may start at a different scale or use a different scale and start at a different point. This one starts at 0. It does use a scale of 1 unit at a time, but mine doesn't show tick marks for each unit. Mine shows tick marks of size 2. So it doesn't look exactly the same, but you can tell that it's not going to look like this, or like this. And most importantly, it's not linear, right? So in this problem, they make us answer this question first, and then we go on and answer the other parts. So we can grab that R value again. Pearson R is 0.816, 53 decimals. And then they get to the meat of the question here. Determine whether there is sufficient evidence to support the claim of a linear correlation between the two variables. I'll go back to the table. We can look at it here. Okay, so with 11 sample pairs, we have to beat 0.602 to be above statistically significant, and to be really strong, we have to beat 0.735. And ours, now that you can't see, let me go back. Ours was 0.816. That's a pretty high R value, isn't it? It beats both. So according to this, we would say there is sufficient evidence to support the claim of a linear correlation between the two variables. Actually, it's the first one right there. And then you can read through the others. You know, there is insufficient, or there's sufficient, there's insufficient. And it says, you know, whether there's correlation or not. But then here's the issue with the last part of the problem. It says identify the feature of the data that would be missed if part B was completed without constructing the scatter plot, and that was in part A. So if you ignored this part and you just jumped right into running calculations, and you know, there's the paper calculation where you can see the whole formula for this. It's pretty lengthy. It can be done in the calculator too. If you want to see that, I can show you. But if you were to draw the scatter plot and first visually check and see if it had a straight line pattern, then you would have actually said that there was sufficient evidence to support the claim. But we should have realized that it wasn't even linear in the first place, so there wasn't going to be evidence. So let's see what it says. The scatter plot reveals a distinct pattern that is not a straight line pattern. There it is. It was A on both of them. So let me submit the quiz and see if we got that right. I know I didn't answer the others. So here it is. We got that one right. And can I go back? I can't go back now. But go and check through that exercise. The point of that problem, and the one that most people missed at least one part, and you can go see which part you missed, and actually still redo it if you have any attempts left on that quiz. It was the part that you might have a strong R value, but if the data isn't linear, then that doesn't have the meaning that it has if it was linear. So anyway, hopefully that helps. And I'm giving props, but proper respects to Jessica for answering the question completely. She said you could go right through that simple linear regression and kind of ignore the rest of the stuff. Which, by the way, while I'm here, in case you get asked these questions, here is for the parameter estimates. Here is the test statistic value right here. So you can look and get more information here. Here's the p-value too. And remember that we always start with the two-tailed test for these because we assume that there is no correlation. In other words, that rho, and rho is the parameter that corresponds with the statistic r, that rho is 0, that there's no correlation. And then we test and we see if that's not true and how strong the correlation is.